Intermediate Algebra Section 1.5. Every equation is either an identity, a contradiction, or a conditional equation. And I'm going to start with the definition of a conditional equation, which is this last one in this table here. An equation that is sometimes true and sometimes false, depending on the replacement of the variable, has a unique solution, and it is classified as conditional. And there's an example here of an equation, 2x plus 5 is equal to 17. And they're giving us that the solution to this equation is 6. Having the single solution, sometimes we have a set of values instead of one unique answer. And when that is the case, where an equation is true for all replacements, and that's this first type, it's known as an identity. The example that I have here doesn't look like it's the same thing, but if we simplify on the right-hand side, 2 plus 3 is 5, so we have an x plus 5 is equal to an x plus 5. Because we're doing the same thing to the variable, and we have that same expression on both sides of the equal, any number will make this true. So our solution set is all real numbers. The third possibility is an equation that is never true. There is no number known such that we can set it equal to itself plus 1. So the solution set that has either empty set designated this way or this way is known as a contradiction. We have some examples here where they're asking us to solve the equation and then classify it. And most of the equations in your study of algebra are the conditional equations where we come up with a unique solution. Let's take a look at these. When we have an equation that has a parenthesis with a quantity out in front of it, we need to eliminate that first before we worry about using any of our addition or multiplication principles to solve for the variable. So distributive means each of the terms inside the parenthesis will be multiplied by 3. 3 times x is 3x. 3 times 2 is 6 is equal to, and while I'm at it, we have similar terms that we can combine and simplify the right-hand side. 5x minus 2x leaves a 3x plus 6. And here we have an example of, right now we can see that we have the same thing on the left as we do on the right. When that's the case, when you have exactly the same thing on the left as the right, we have an identity, and that means our solution is going to be all real numbers. If we didn't catch that we have the same thing on each side and moved on to put the variables together, we could subtract a 3x from each side. That should be an indicator that something's up because the variable disappears, leaving a 6 equal to variable disappear equal to a 6, which is also an identity and true. And in terms of a solution then, anytime we have an identity, it means that our solution will be all real numbers. Any number will satisfy this equation and make it true, and we can symbolize that with this symbol representing all real numbers. We have another equation here that they're asking us to solve and classify. If we come up with a unique single solution, it's a conditional. Let's see if that's the case here. There are no fractions to eliminate, there's no distributive to use, but before we jump into addition and multiplication principles, let's simplify. The left-hand side, these are not similar, so we'll leave them as is right now, but on the right-hand side, we do have similar terms. we end up with a 3, and combining the x's, negative 9 plus 4 leaves a negative 5x. Well, both sides of these equations look somewhat similar, but we don't have an identity. The next step would be to get the variable on one side or the other, and here's where we're going to see a problem occur. Negative 5x plus 5x cancels out the variable on the left, leaving 7. It cancels out on the right, leaving a 3. X is not equal to 3. This, of course, is false, and that leaves us with no solution because we have a contradiction. There is no number known in the real number system that will satisfy this equation. So as far as classification, we're calling it a contradiction. And in terms of our solution, we can either state it as the empty set here, or we can use the brackets with nothing inside of it.